This is a screencast on OVNs in OVN using SFC. If you're not interested on that, then this is not for you. All right, for the rest of us, 3 VMs in a central VM. 3 instances, and they really are namespaces that we're just gonna stamp out inside these various compute nodes. To make service function chaining, we're gonna use VNFs. So I'm gonna put, in this demo, we're gonna have 3 VNFs stamped out. So start with the chain. So I start with this one. I call it chain 1, 2, meaning from instance 1 to instance 2. We're gonna divert the traffic instead of letting OVN do what it would normally do, which will be taking the traffic from here to there. It's actually going to be diverted into VNF-A, VNF-B, and back to 2. If you look at the next chain, call it chain 1, 3. If instance 1 is trying to talk to us in 3, we're going to force it going to C. Or 2, instance 2 going to 3, we're making it going that way, and from 3 to 1, we make it go that way. So basically, this is the spaghetti we're creating today. Okay. And it's stored in here. This is going to be running inside a namespace, and I renamed the interfaces to ETH1 and ETH0. And these are the actual functions that do anything different. You create port pair, which you create an input and an output. And notice that for this demo, VNF-B has different in and out ports, whereas the VNF-A's and C have the same in and out port. So we just listed twice there. This is where you create a port chain. We are creating 5 of them. If you can look at create a chain, and you tell what the last hop is, basically. So chain 1, 2 ends at switch port 2. 3 for 3, and then it goes. Port groups. Now, port groups are a group of port pairs that you associate with a chain. So chain 1, for instance, chain 1, 2, we actually have 2 hops. You can look in here, hop, 1, 2, and then back. So that's why we actually create 2 port groups, and they really matter because you can actually, I don't show it in this command, but you can add an offset parameter to them that tells you the order in which the port groups are going to be visited. Port groups contain a list of port pairs, and that's load balanced. And that's what I do, if you look down below here, that's what happens right here, where we're associating a port pair to a port group. So on chain 1, 2, first hop, right, port group H1, go to VNF-A. Second hop, go to VNF-B. Now the classifiers, which is the last piece, which is we're really extending the ACL commands to now have an SFC action and also provide options. So you can have a map of strings here. In this case, you need to tell the classifier which chain you want that to be to. Start the OVN cluster as you normally would. I have little scripts that do that for you here. 3 shell scripts that basically do the 3 steps, create the normal instances. Script 2 creates the VNFs and the chain. And script 3 starts the little app that runs inside compute 3 to do the NFV app. You can actually go and look at the northbound, and you can see, pretty much the ports, just one switch. Southbound, let's look at that. So here is a little more placing the VNFs on compute 3. You don't have to be in 3. This is just a convenience thing. I'll show you in a minute why. Let's go ahead and look at the chains that we created on our little script. So I can do this here, and we pretty much see what the script created, right? So we have a chain. I'm telling you to show chain 1, 2, the 2 groups, and inside the groups the port pairs. Right, so I have 1 port pair inside this group, 1 port pair inside that group, and these are the VNF ports that they comply, the flows that got created. So here the output for the very first port in the chain and the chain itself, where we're pretty much having a tuple of the import and the destination. For doing this development, I used the OVN trace tool. So here I'm just creating a little packet rule, and I'm telling OVN trace, hey, OVN trace, where would it go? So this is a very nice way of actually showing, without even doing a port bind, ping packet from 1 to 2, and then you can actually continue that following to the other ports, and you can see, okay, now if I came in from port A, where would I go? Well, you end up in port B in. These apps, they spit what's going on into a log file. So if I do a tail on them, like that, I'll pretty much see all the activities that happen. So if I went back to compute 1 and did our ping of 1 to 2, right? of course we will get a reply, but we also can jump back into the log and actually see that the packet visited the VNFs, right? So it hit VNF A, and this is our ping request. If you remember from the chain, it should have gone is 1, 2, 3, hit A, B, and go guess where it needs to go. So this is really it, right? Echo request and the reply from 2 to 1 right here. Okay, another example. If you pinged 3, you would see the packets hitting VNF-C twice, right? On the way in and on the way back. So this is the echo request and echo reply. And that's pretty much it. This is the all at, and hope you like this demo. All right, bye-bye.